So talk is everything you never knew you wanted to know about Passkeys. And back in February, when I made this title up, it was very clever because Passkeys were still writing kind of under the covers. There wasn't every week or every day that we were hearing Google announce something, Apple announce something, Microsoft announce something, 1Password announce something, Okta and Ping and everyone kind of dogpiling onto this. So that is the title, and people probably know things about Passkeys now, but this is a one-on-one session, so hopefully we will be able to talk about the technology, talk about the tools that underlie the technology, and talk about how you can take these back to your organizations or back to the products that you support and use them to make intelligent choices as you improve and further secure the authentication process. First, disclaimer. Everyone loves disclaimers. That's enough to be said about that. Next, who am I? Hi, I'm Josh. I'm a solutions architect at Ubico. We make the YubiKey, hardware authenticator. In the solutions architecture space, I have a great job where I get to focus on standards and I get to focus on regulations and understand what that means in the authentication and the authorization space and then translate it for other people. So I'm writing white papers all the time. I'm commenting to customers. I get to give presentations for the Office of the CTO talking about, oh, this means this in Europe and this means this over in Japan and this means this here and there. And I get to read a lot of stuff and I get to understand a lot of stuff, and reading and understanding is a great place to be. As far as professional organizations, I'm a contributor to the Enterprise Deployment Working Group with the Phyto Alliance. We're actually writing best guidance and best practice on how to take phyto technology and roll it out in enterprises. I'm also a member of the Cyber Resilience SIG for ISSA. Again, we're looking at best practices to ensure that cyber systems maintain functionality and can be recoverable easily. I'm also a recovering editor for the ID Pro Book of Knowledge, which means that I have edited quite a few articles, but I fell off that wagon a couple years ago, and I'm trying to get back on again. In my general life, I'm a big nerd. I've got way too many board games, and as someone who likes to read and understand standards and regulations, I do a lot more reading of rule books than I actually do playing board games, which leads to like 2 to 3 shelves worth of board games. We've touched maybe a third of them. I'm a bow tie enthusiast. I always encourage bow ties. I'm a low-brow beer snob, which means I like to go drink. And every couple months, I ask myself the question, is there such a thing as too many Legos? And then I test that question, and the answer is still no. Last but not least, I consider myself an IGA evangelist. I like talking to people about building better systems, better authorization systems, understanding how identity impacts users. Just the last talk we went to was about how they love passwords. And it wasn't about loving passwords, it was about understanding your users and building good systems so that users will adopt whatever type of authentication and authorization you're foisting upon them. And that's really important. And that kind of segues really well into what are passkeys. So this lovely definition was taken from the Phyto Alliance. Again, Phyto Alliance is a large group of different organizations. I believe there's about 84 different members, all different realms and regions. We've got healthcare, we've got finance, we've got Visa, Discover, MasterCard are members. You've got Google, Microsoft, Apple, Yubico. They all contribute to the phyto standards for phyto authentication. And they came up with this giant mouthful of words, which really can be simplified to this. Passkeys, little p passkeys, are phyto credentials designed to replace passwords, to make users' lives easier. And whenever you see passkey, you'll see this little guy. He doesn't have a name, but I like to think of them as Passkey Pat. So if you are using passkeys and you're building UX, you want to use that type of iconography. So I've said Phyto Alliance and phyto authentication a couple times. So then natural question is, for those of you who don't know, what is phyto authentication? So this is phyto in a nutshell. We can make it really easy by comparing it to passwords or comparing it to legacy authentication, where Passwords were human-generated symmetric secrets. Both sides, the user and the RP, needed to know the same piece of data. With phyto, it's a machine-generated, very randomized, public-private key pair. The user gets to hold and utilize their secrets material, their secret side of that PKI, public key cryptography certificate, arrangement? I'm blanking on the word. I apologize. The user gets to hold their secrets material. It is never exposed to anyone. When they go and register an account or when they go to do an authentication, the RP, the relying party, the SSO provider, they use the public key to challenge the user to prove they have the private information, and that is how this works. It means that RPs no longer need to worry about storing secrets material. It means you no longer need to worry about having big hashed tables of passwords, because all you're worried about is public keys, and public keys are public, so they're out in the open by design. With passwords, passwords can be reused. There is no checking to see where a password is reused. There is no checking to make sure that passwords haven't been used cross-platform. With phyto, keys can be generated so that they are bound to a single relying party, which means that if you so choose, when you are building a system, you as the RP can talk to the authenticator and say, generate a new key pair, only use this key pair when you're talking to me. Passwords are easily phished. Again, in the last talk, they made the great, they reinforced the great study that was done where people in a parking lot were approached, hey, will you give me your password? I'll give you a candy bar. And it works. Phyto is phishing resistant. Even if someone comes and gets my phyto credential, they need additional pieces of information in order to access it. And because it can be bound to a single RP, it's not like you can take it and use it necessarily other places. Last, passwords. There's lots of attacks against passwords. You've got credential stuffing, you've got social engineering, you've got leaked large tables of cached tables of passwords. When you're talking about phyto credentials, they're impractical to remotely compromise. Yes, you can install malware on a user's machine, and yes, you can compromise the login process that way, but if you've got local malware, you've got a bigger problem already. Relying party. So whenever you stand up a system that needs to get logged into, that's considered the relying party. So who has a passkey already? Raise your hand if you've got an Apple device. Raise your hand if you've got an Android device. Raise your hand if you've got a security key. Congrats, you've all got passkeys already. With its rollout of iOS 16.2, Apple gave you all passkeys. And with a very recent update to Android, again, Google gave us all passkeys. It's the primary mechanism that Apple and Google are using to authenticate that a device is secure, and it is the primary authentication mechanism that they're using to do validations against their back-end systems, their iCloud system or their Google account. So if you've got those technologies in your pocket, you're using passkeys today, and you don't even know it. And that really is the UX process, the user experience process we should all be aiming for. You can roll these systems out using the standards, using the best practices that the working groups have put together, and you can make it invisible to people. And when things work like magic, when you rely on fingerprint or Face ID that people are used to, don't necessarily tell them how it's working underneath, but rely on those technologies, you can really drive adoption and improve your security footprint at the same time, security posture at the same time. So earlier on, I said little p passkey, and it's kind of important to understand that there is a difference between big P passkey and little p passkey. And it's really Calvin ball right now. There are no rules. The technology, as far as the phyto standard goes, is passkey with a little p. That is the standard, that is the name of the underlying technology. When you are reading announcements, when you are reading papers, if it says little p passkey, you can understand that they're talking about the standard. If you see a situation where it's a big P passkey, as long as it's not at the beginning of a sentence, that is implied that it is a vendor's implementation of the standard. So Apple Passkey, or Google Passkey, or 1Password Passkey, or Microsoft Passkey, because Microsoft announced that they're rolling these out in the next couple months as well. The Passkey standard is interoperable. So if a device supports Apple Passkey, you should be able to use it where Google Passkey is supported. However, they are different ecosystems, and when we start talking about some of the advanced features like synchronization, that's where things kind of get murky, and that's where we still have some lines drawn between different implementations. So, brief talk about how passkeys work. This is public-private key cryptography. Again, user generates a public-private key pair. So they get a public certificate and they get a private certificate. They then go through a registration process where they go do an identity proofing, and they say, I'm me, here's my public key. And depending on how the RP, depending on how the relying party is configured, the relying party can say, great, and just like associate that public key to that user, or the relying party can say, hi, you, I'm me. And let's go through this extra special dance where you create a different set just for me. And that's like a domain-bound passkey, where you have a single passkey that is used only to authenticate against that provider. You can use those in situations where you want to do passwordless authentication, or whether you want to do a usernameless authentication, where you have a public-private key pair that is the private key is controlled by the user. The RP has been assured that that private key, that public key and that private key are only used for their system, so that they can connect that to an actual user and, authenticate on your phone, and Bob's your uncle. No need to put in a password, no need to put in a username, no need to put in anything, because it's all cryptography on the back end. This is kind of what the authentication request looks like if you are using just a generic public-private key pair, one that's not associated to a particular RP. User makes a login request, it goes to the IDP, RDP in the back end. The IDP sends a challenge to the client, which is either an app or a browser. That client then takes the challenge as well as the origin where the challenge came from, sends it down to the authenticator. The user does a proof of presence, and then it loops back up again. It gets signed by the authenticator, the credential and the signed response gets handed to the client goes to the IDP, and then the IDP logs the user in. It's very important that this is a bidirectional flow. Historically, MFA has been unidirectional, meaning you get a SMS code. You can put that SMS code anywhere. That SMS code says nothing about who generated it or nothing about where I'm entering it. And that's why we get replay attacks. That's why we get attacker in the middle attacks, because there's no verification of the origin and there's no checking to make sure that I'm actually putting this into the right place. Same can be said about like push notifications. Same can be said about number matching. There are no inbuilt mechanisms that do that origin checking because it's not a bidirectional process. There's no check, counter check, sign, countersign. It's just one way. So why do we say passkeys are easy? This is some of the advanced features, or these are some of the newer developments in the FIDO2 standard that are really meant to drive usage and encourage usage by users. The first is sharing and syncing. Historically, you wanted an authenticator, you would get like a hardware device like this, and you would give it to a user, and you would say, plug this into your computer and tap on it, or tap it on your phone, and that's great until they lose it. And then you have to worry about a re-registration process, you have to worry about temporary validation, you have to worry about step-down authentication or step-up authentication in order to go through all that. With passkeys, they can be synchronized across ecosystems. So if you generate a passkey on your iPhone, it gets synchronized to your iCloud account. The secrets material, the secret key, actually gets synchronized to your iCloud account, and then you can use that on any device that is tied to that iCloud account. So you can generate a passkey on your iPhone and then go to your Mac in Safari and log into the same site using that passkey. Some providers allow for synchronizations across ecosystems. Again, that's the iPhone, where everything tied to your iCloud keychain can be synchronized. Some providers allow for synchronization across devices. These are historically your password managers. 1Password is actually getting into this game. Again, because Apple Big P Passkey is limited to iOS devices, what do you do if you have a fleet of users, half who are on Apple devices, half who are on Windows devices, with iOS and Android mixed in for fun? 1Password has a scheme where they actually store the secrets credential out in their cloud. You use their plugin or their 1Password tool, and you can pull that secrets material down and use it on whatever device you want. So again, the usability really is what the usability and the replaceability is really what drove this functionality and this feature set to be put in place. The second point, or the second part of why passkeys are considered easier than some other authentication mechanisms is leveraging inbuilt patterns that we're used to. Everyone's used to pulling out a phone and scanning their fingerprint or doing Face ID to unlock their phone. Why can't we take that we have trained our users to do, we've trained our customers and our consumers to do, and use that as part of the authentication process or part of the login process instead of having them punch out a, tap out a 16-character password or whatever. So the authenticators, the actual hardware, leverage inbuilt platform tools for those checks. Lastly, there's a lot of work in the UX space, especially around, I will get this wrong and I apologize, conditional UX autofill, which means that when a browser encounters a login, instead of the password manager saying, I have a stored password, the password manager can say, I have a stored passkey for this site, and just show that little passkey pad icon and click on that and log in that way. And the point of that UX really, again, is to hide all of that complexity and hide all of the confusion from the users. So we have two different models for passkey storage. The first is syncable and copyable. It's ping-ponging all around here. Again, passkeys can be flagged to be synchronized across devices. Other high assurance use cases, you can have device-bound passkeys where you've got a single device where that key is stored and it can be used in multiple locations. And that's your, your inbuilt TPM on your laptop, or that's a removable security key or something like that. When you are designing your use cases, when you are planning things out, it is important to understand that these are really the two architectures you can go with. And for the best adoption, choose both. I mean, some people like the heightened security that this is. Other people like the ease of use and kind of recoverability from the syncable and copyable. And you can support both at the same time. One of the aspects of passkeys is that you can associate multiple public keys to a single account. So you can kind of like pick and choose from the best if you so choose. So in that first side, where we had stuff going all over the place, there is a question of how to present this in a way that makes sense to users and how to present this in a way that makes sense to decision makers. And Google has come up with the term sync fabric. It's a way to discuss all of the individual places a passkey exists. It can encompass both cross-device and cross-platform models. So that's the iCloud or the like 1Password password manager model. It also describes how sync credentials can move from one authenticator to another. The thing to remember about the synced passkeys, is that the different nodes don't necessarily need to be aware of each other. So this means that I can create a passkey. I can create a passkey on my iOS device. I can then take that passkey and share it to you over there. You can then log into that site with that passkey, register another passkey from your Android device, and I would not necessarily know that your Android device also had a passkey that was associated to that account or to that credential. So when you're designing your processes, make sure you take this into account. Make sure you keep in mind that syncability is great for recoverability. Syncability is great for usability, but it does have some faults that you want to call out and you want to be aware of. Sync Fabric is kind of what the Phyto Alliance is discussing internally right now. It is Google's proposed terminology. It may or may not be accepted in the official standard this way, but some concept of this all-encompassing picture of everywhere a passkey lives will wind up there somewhere.
Is it,
yeah?
Is it mandatory that you use IP6
No.
when you're using that?
Nope. Yeah. The question was, is it mandatory to use IP6? And the answer is no, it is, it doesn't care. I mean, there are reference implementations that use a QR code that's been printed on a piece of paper that you can then use to authenticate.
Well, I was just saying that because you have all the information about the device that's going to IP6.
Yeah. Yeah. So this is a good overview of kind of what gets synchronized. In the authentication process, you've got two main bodies. You've got your client and you've got your authenticator. And the secrets material lives on that authenticator. With Passkey, what we are enabling is the migration of the secrets material from like one device up to the cloud down to another. Things that don't get copied are pins, are biometric data, and attestation certificates. Attestation certificates are certificates that talk about the authenticator itself, not necessarily the secrets material that is being used for authentication. So if you need to say, I want to know where this, like what authenticator was used, you would be looking at your attestation certificate. If you just wanted to make sure that it was Josh who was doing the authentication, you can just rely on the passkey. But that attestation certificate, and again, any kind of PIN or biometric data, is all stored locally, and that is not synchronized. So how else do passkeys work? Getting into this a little bit more technically. There are two main protocols that make up the phyto 2 standard, webauthn and CTAP2. Webauthn is what you will be dealing with 99.9% of the time, if you even need to deal with it at all, if you're not just buying a product off the shelf. Webauthn is an established authentication standard. It's accepted by the W3C. Again, public key is associated with the user on an RP. It's supported by most major browsers. And it interacts with the CTAP protocol to talk to the authenticator. CTAP, or the cleverly named Client to Authenticator protocol, is what facilitates the actual interactions at the OS level. So the CTAP protocol is what's doing the heavy lifting, talking to your TPM, talking to your secure enclave, talking to an external security key. It's extensible to include that attestation certificate we just talked about. So if you need additional information about where that certificate came from, where that certificate currently lives, all of that can be gathered with the CTAP2 protocol. And the best part is, most of the time, you don't need to touch it. It is built into the operating system. So unless you really want to have a bad time, you can just leverage inbuilt libraries to do all of these tasks. So again, putting it together, relying party, that's the software service that wants you to authenticate. Relying party uses webauthn to talk to the client. That's your app or your browser or just an operating system. The client then uses CTAP to talk to the authenticator, and Bob's your uncle. So again, we have bidirectional communication. Things are broken up quite easily and quite separately by design. Phishing resistance. So phishing resistance is a thing that everyone is looking for these days. Basically, it describes ways to overcome the challenges we spoke about before with legacy MFA. If you have read any kind of regulation, if you've looked at any kind of, governing body that says you need to roll out some new authenticator or some updated authenticator, the terminology they want is phishing resistance. NIST has gone ahead and defined two types of authenticators that meet those phishing resistant standards. One is PIV, the other is phyto2 or Passkeys. Again, legacy MFA is unidirectional. There's no check. There's no talkback to make sure that you're actually logging into the right site. So with a legacy MFA system, you can be hitting a proxied site, or you can be hitting a dummy site or a copied site, and the attacker can then take that one-time passcode and just inject it into the real site. And that's how attacks happen. Like that's how credentials are compromised, and there are off-the-shelf software as a service phishing toolkits that do just that. You say, I want to attack their Google site, and they pop up a fake Google site, or they pop up a proxy Google site and send it to the user. Someone clicks on the link, puts in their username, puts in their password, or clicks the authenticator, and the cookie is then captured and handed off to the bad guys, and the accounts are compromised. Again, because there's no validity check of what's called the origin URI, the origin that the request came from. WebAuthn, back in that early slide, we said that the origin data is actually included in the information that's handed off to the authenticator to do that check to make sure this is the same origin that I originally registered with, and then it's included back. If you try and, ooh, that's supposed to be imposter. My proofreader said that they caught a spelling mistake, and it just popped out now what it was. If with a passkey you try and authenticate against a site that is proxied or is an imposter site, the returned signature will not be valid, because that origin that the browser actually got the information from, or that the client actually got the information from, is used as part of that signature. So even if an attacker can get that far, the return value that they get is only useful on their bad site, not an actual site. With Passkey, it was determined that we needed to find a way to kind of breach or move credentials from laptops and desktops or kiosks to mobile phones and back again. The terminology for this technology was originally cable, which is something over Bluetooth low energy. Smartly, they have rebranded it to hybrid transport. What hybrid transport does is it allows you to register new keys when you are not on the original device, and I'll actually demonstrate this a little bit later. It uses QR codes and Bluetooth to facilitate that transfer. So you also have the added benefit of having to be geographically co-located in order to do this. You can't have someone like pop up a thing on a screen and you scan it and then have a remote computer capture that. It uses BLE to check to make sure that you're in the same area. And
so your location services have to be enabled for that to work?
Your location services don't need to be enabled. Your Bluetooth stack needs to be enabled. Yeah. Announcements are dropping all the time. At a Worldwide Developer Conference last week, Apple announced that you can use Safari to share passkeys across groups, which I'm sure Netflix is super happy about. I actually spoke to Netflix the week prior to that, and they said that they're not doing passkeys, but that's another thing. 1Password just last week announced beta. You can install their beta plugin, and you can access passkeys across devices, across platforms. It's really, really nifty, really sweet. If you've used 1Password or any kind of password manager before, the UX works really surprisingly well. There are actually more announcements, but I had to cut it last Thursday. Again, Microsoft just announced Friday, I think, that they are moving into the space in the same way. Firefox just announced support in their upcoming browser for not only the acceptance of passkeys in their Firefox password manager plugin, but also ways to better manage passkeys on the local computer, which is very useful if you're in the Linux world, because there's not really a good way to manage those passkeys elsewise. Watch this space. There are lots and lots of announcements dropping. And again, when I came up with the idea to give this speech back in February, it was, this isn't very well known. This is kind of on the undercurrents. We were at a lot of conferences last year, at the beginning of this year, and people were still kind of scratching their head, what is this? And it seems that since then, there have been a lot of announcements. And again, if you've got a phone in your pocket, you're using this technology today, which is great. So where can we use passkeys? And this is out of date. Again, I apologize. There should be some checkboxes here and some checkboxes here. Everywhere. Everywhere is the answer. In some way, shape, or form, every major operating system and browser platform supports this today. So these companies have done a ton of the work kind of bringing this up to speed. So if you're responsible for users, or you're responsible for customers, or you're responsible for a platform, there's no reason why you can't take this and implement these today. So again, passkeys, multi-device phyto credentials, single device credentials, only on this side here, but these are kind of being phased out in favor of, just normal passkeys. Security keys across the board, fairly good adoption, except in the Android space where there are some OS limitations. Yes, this question.
Are those asterisks meant to represent X's?
No, those are asterisks meant to represent. It kind of works, or it works, or it's been announced. Passwordless, which is kind of the end goal of all this, works really well in iOS, works really well on Mac. Some support in Android, and it works well enough in the browser on Windows, but not in like native apps or not on the OS yet. Again, this is out of date because Microsoft just made more announcements. And the last one, Passkey autofill, conditional UI. These are a lot of the UX standards, UX improvements that we are looking at and that we want to see driven and adopted. This is where users get that, pop-up passkey experience where you go to a page or you open an app and it just like pops up a box and you hit it and it works. You'd be surprised, especially Apple's implementation works surprisingly well. They have done a lot of tuning and they have done a lot of research, and I think that they have learned from a lot of missteps that password managers and password kind of centralization tools have made in the past to put together a really good invisible process and platform. So if you've got an iOS device, you can go to the demo set I'm going to show in a couple minutes and try it out and see how it works. Benefits for your organization and or platform. Passwords are bad, okay? I don't think we need to say any more about this. I feel really bad because the last talk we were in, or the last talk I was in was like, I love passwords, and it's true. I love authentication. I love this concept of identity, but it is bigger than just like the password itself. And I am tired of writing password policies. I am tired of enforcing password policies. I would rather just take them and throw them out the window. And that's one of the things that Passkey is really aiming to do. Passwords inherently aren't bad. Passwords are, it's a shared secret. It's a way to prove yourself. But it's abused and it's weak, and we're all human, and we all have faults, and we all have bad days. So why not use phones or use computers to do the things that we invented computers to do, which is make our lives easier? And passkeys are really a way to accomplish that. They allow for passwordless workflows. 50 to 80% of all cyber incidents are caused by compromised credentials. Again, you can walk up to people in a parking lot and say, hey, give me your password. I'll give you a candy bar. And they will. Less passkeys, less passwords means less risk all around. And even if you need some passwords for admin accounts or for break glass accounts, if you're reducing the number of passwords that you rely on overall, you're shrinking your attack surface. Again, passkeys, backup and recovery. Synchronization allows for easy recovery. You can take your phone, you can throw it in the ocean, you can go to the Apple Store, buy a new iPhone, restore from iCloud, and you've got your secrets material again. And they're easy to use. And again, this is a lot of that UX work that's being done in the browser and being done on the platforms to make sure that they are usable and acceptable. Some of the challenges and pitfalls to keep an eye out when you start planning this. Synced keys, again, have no visibility necessarily to each other. So you can create a key on one platform, migrate it over to another platform. There's no inherent communication between the two. Phyto adoption. Most RPs support phyto today, but your mileage may vary. You might still be running, a AS400 or a mainframe system, and have to like work around those hurdles. So understand what your platform looks like, understand what your environment looks like, and take steps as necessary. While syncability greatly increases the ability and survivability of those secrets materials, you still need to plan for re-enrollment. Not we all, but anyone who has in the past had anything to do with the help desk knows that Monday morning is the worst day for help desk because everyone is calling, I changed my password on Friday and I don't remember what it is. You get to get rid of all of those phone calls, but you still need to manage the, I don't know, I locked myself out of my iCloud account, and Apple has decided that after 10 failed attempts, they have just nuked it from orbit. I need to enroll a new passkey. So those are the types of support processes and support workflows you need to make sure are documented if you go this route. And last but not least, know your customer. What are people willing to do? Maybe they don't want to use their phone for authentication. Maybe you need to make sure you have other mechanisms for them to actually hold those secrets material. Maybe you have a call center with a no phone policy on the floor. You can still achieve this using other mechanisms, TPMs on computers, security keys, but know what your customer base looks like, know what your user base looks like, and plan accordingly. So, again, I'm from Ubico. We make the YubiKey, little hardware bits of plastic. We like selling them. How do passkeys and security keys play together? And the answer is they're the same thing. Security keys are just another authenticator where a passkey can live. More adoption of passkeys means that there are more places you can use a security key. If you have a security key and you've tried to use it, places today, there's not a ton of places like out in the public. Kayak supports it, GitHub supports it, Microsoft supports it, not as much. With the adoption and with the growth of passkeys, we're seeing more and more and more publicly facing organizations support it. I know that Sony is rolling stuff out for like PlayStation Network, so you'll be able to use like passkeys or security keys to sign it to PlayStation, which is really cool. 1Password has a whole big list of places where they've seen recent passkey adoption, and that list is growing day by day. And again, it's a use case situation. Your syncable passkeys, they're great for consumers and for low assurance use cases. If you've got a situation where you have a high assurance use case, you need to achieve like AAL level 3, you can still leverage all of the same technology, all of the same standards, and everything is phyto passkey. It just lives on a hardware key instead of your phone or your laptop or somewhere in the cloud. A wild demo appears. I'm gonna attempt this. See how well it works. So if you want to kind of try out the passkey experience, passkey.org, we set this up. It works really well. So we are going to sign up with a passkey. I'm going to do, I guess that's my name now. Let's go ahead and sign up. The username is available. That's fantastic. So this is the UI that the Edge browser is popping up. It's saying, I want to create a passkey. Where do you want this passkey to live? You've got multiple options. I can do it my Windows Hello. I can do it on a device that's already linked to my phone, to my machine, or I can do it on, or I can use that hybrid transport that we talked about before. And so let's go ahead and do that. So if anyone has their phone and wants to register a passkey for my account, you're welcome to scan right now. Otherwise, I can try and do this. Let's see. Excellent. So here is my phone. I'm going to open up the scan app, and we're going to go and try and scan that QR code. And let's see what's going to go on with the projector being right there. There we go. So I don't know if you can see that. There's a little tag that pops up. It's phyto. It's going to come up, connect with QR code, allow. It's connected to my device. It gives me some information. It says create a passkey. This passkey will be bound to passkey.org. It's going to be saved to my Google account. Going to hit continue. It's asking for a fingerprint right now, so I black the screen out. And there we go. So I have created a passkey in the browser for passkey.org. That passkey is currently living on my phone. So let's go ahead and go to passkey.org. We're going to sign in with a passkey. Again, the UX determined, hey, you've got a passkey for this site already. I'm just going to select that one. I continue. Again, do a security proof. It's still multi-factor. It's still something I have, which is the private key that lives on my phone and something I am, my biometric, and I'm signed in on my phone. You can then go ahead and register additional devices. You create additional passkeys, but that is the experience. It is painless. It is incredibly user-friendly and user-focused. Like the fingerprint ID, the little UX pop-up that came up, it's all things that people should be used to seeing. If they're using the Google Password Manager or they're using the Apple Password Manager, they build on all of that design terminology, and they build on all of that kind of design language just to extend that.
Sorry, where did you use your fingerprint? Was it when you went to Passkey, or was it?
When I created the passkey, it does a check. It does called proof of presence, which is it does multi-factor authentication. So again, I am who I say I am. I have to use my fingerprint to unlock the secure element on my phone, and then when it goes to check, it uses the fingerprint to do the unlock of the secure element as well as verification that I am me, or at least I have my thumb. Exactly. Okay, so just as an overview, vocabulary lesson. Passkey, FAT2 credential. Single device passkey, it's a credential that's bound to a single authenticator, like a security key. Also sometimes called a roaming authenticator because you can pick it up and it can walk away. Multi-device passkey, it's a credential that can be synced to more than one device. Hybrid mode is the ability to move from platform to platform, meaning you can go from phone to desktop to phone to kiosk to billboard on the side of the road if it's a smart billboard. Authenticator is just a device that holds credentials. Again, roaming and platform right there. Last, device public keys. Kind of snuck this one in there. This is another proposed extension to the webauthn specification, and it is what lets you get that additional attestation certificate information off the authenticator. How do you use passkeys? Again, check with your RP. You can also build your own, like RP if you wanted to, that accepts FAT2 credentials. Developers.ubico.com, our developer lead, Luke, ran a course, recorded the whole thing. It's really good. There's a Docker image there. You just spin up the Docker image, and then you can tie it to whatever application you like. Further reading, official, quote-unquote, links. Passkey.dev is the official phyto site. Passkey.org is the one that we just used that was put together by Ubico. Phytoalliance.org/passkeys if you want to read the standards. Developer.apple.com and developer.google.com. And then community links. I like this last one a lot. He is just grabbing everything good, like every good resource about webauthn, and just surfacing it. So I'm not going to pronounce that name. I'm going to maul it. The link's right there, and the deck will be available later on. And that's all I've got. So are there questions? Please reach out to me, Mastodon, LinkedIn, email. That's my cat. Put a cat in your PowerPoint. I saw a question here, and a question here. Question here.
So we're talking about just sort of kind of transportability. That's been my main thing holding me back. It just seems very, like, how easy is transportability? portability across devices, across stuff like that. If I really need to, do I need to create two separate passkeys for my Windows device, for my iOS device, or is that something, since they aren't necessarily aware of each other, I can just send off to the other device? That's the thing I've been a bit confused about.
So in the long ago, that was the plan. The question was about portability. In the long ago, that was the plan, where you could just pick up that secrets material and move it anywhere you wanted. We have, and we means the Phyto Alliance, has kind of done some further thinking, and that's where your hybrid mode comes into play, where the standard says that RPs should allow you to associate multiple public keys to individual accounts, and then you use hybrid mode to create passkeys on each device or on each platform. Next question was here, and then I've got back there.
What's with the 25 phyto2 limit on YubiKeys? Like, what exactly is going on?
Sure. So the question was about the number of credentials that can be stored on a YubiKey. Particularly, I can talk about this. It has to do with the amount of storage that's actually in the secure element. When the secure element was designed and when the firmware was written, we needed to come up with a number that was reasonable. Space exists on that secure element, but it is not infinite. And 25 was the number that kind of came up. But you only are limited to 25 credentials if they are detectable credentials, meaning if they are associated only to a single RP. If you create a passkey on a YubiKey, a phyto2 credential on a YubiKey as your non-linked, you can use that multiple places.
So in a non-linked credential,
Yeah.
two different RPs, will they have the same public key material?
Yes, they'll have the same public key material because, again, it's a public key and it's meant to be public.
Okay, but with a reserved site where it's part of that 25 limit, an RP that is using that one of the 25 slots, they will have their own unique public material that's different from.
Yes, that public material they can take that public material and toss it to the wind because, again, it's a public key and it's meant to be public. However, on the private side of the house, the certificate includes checks to make sure that it's coming from the correct RP. One more question over there, and I think we're at time. I think I'm going to get the 2 minutes. Okay, quick.
I just want to say this thing is the real deal, and we are, in my organization, I'm pushing an effort to really aggressively move away from using passwords entirely, and this is the way that we're doing it. And what we have found is the technical challenge of owning and deploying this thing, and we use Okta, so it's somewhat easy, in a scalable manner, is so much better than is a good challenge, and it's so much better than the bad people challenge of people forgetting their passwords.
Yeah.
So this has been really good to us so far. We haven't had any technical issues, and just definitely keep your eye on this. This has been a great presentation.
Yeah, thank you. Like I said, first and foremost, I'm an evangelist. I like IGA, and solving those problems is like what I like hearing. We had one more question over here.
Is any of the information that's stored in the browser vulnerable to capture from stealer malware or otherwise able to be used in a recovery attack?
I am going to say maybe. And again, if you've got malware on your local machine, you've got bigger problems.
Well, I'm talking specifically about malware that folks encounter on the web that is really light touch, infects the browser, tweaks itself, and generates those massive logs we're seeing on the dark web.
I don't know. I don't know if we have done any specific research in that space or if there's been any specific papers published in that space. Again, the way that the two protocols, webauthn and CTAP, work together insulate a lot of that. But if there is local malware on a machine, regardless of what flavor it is, there's only so much that can be done. It's a maybe, right? That malware would still need to intercept and manipulate the CTAP execution, which is difficult. But I am not going to say it's impossible. But I don't believe we have seen it in the wild. And I have the message. So thank you so much for being here. There was birthday cake upstairs. I really Really happy you came to see me. 2 or 3 more stickers over there. Please go and take them so I don't have to bring them home. And enjoy the rest of your con.